All right, so just a couple quick announcements, and then I'm happy to open things up to questions. Otherwise, I've got some prompts that maybe will help generate questions. But basically, the plan is today we have this midterm review session. No new content today. It's just review of all the stuff that we've gone so far to prepare you for the next lecture period, Tuesday, midterm stage 1. So this is 80% of your midterm score. And it is an individual exam, closed book, closed notes, but you can get 2 double-sided formula sheets. You don't have to put formulas on them, just whatever you think could help you, but it has to be self-produced. So I don't want any photocopied material on this. This semester, due to the wide variety of locations that we're taking this in to keep things fair for everybody, we're doing everything on Respondus for stage 1. So Respondus lockdown browser on Canvas. So basically, Tuesday, like at midnight, Tuesday morning, then, so I guess technically Monday night, then the availability window for stage 1 will open. And at that point, you can start stage 1, which is available in the unit F2 module, and you'll get 90 minutes at the instant you start it. And then you can take it anytime that day. You can start it anytime that day, but once you start it, you've got 90 minutes to finish it, and you have to take it within Respondus lockdown browser. During that, you'll show me your formula sheets. I also allow you to have some scratch paper, but you have to show me like the 2 blank sheets of scratch paper in the beginning of it. You'll finish that up. If you want, you can come here Tuesday at this lecture period, and you can take it with your laptops in the class here, and I'm happy to proctor during that period. The only catch is, although I provide 90 minutes for online, just to account for any technical issues, I can't provide 90 minutes here because we have to get out of the classroom, and I can't have people closing their laptops, sharing information with each other, then opening them up, in that that 15-minute window that's afterwards. So I have to make sure that when people leave, that that Respondus will record you as having submitted by the end of the normal class period. So if you come here, you'll be limited to those 75 minutes, but if you're at home or somewhere else, you've got that 90 minutes just to account for any technical glitches that might occur. Once you're done with that, then, oh, and I forgot, I also made this change. So the availability window, I'm actually gonna make Tuesday and Wednesday. So if for some reason, there's an issue that you don't wanna take it Tuesday, you can also start at any time Wednesday. So you've got that 48-hour period to take stage 1. Anytime Tuesday, anytime Wednesday, you can only take it once. And once you start it, it's timed, and you have to finish it within that timed window. Then Thursday midnight, so technically Wednesday night at midnight, then stage 2 availability window opens up. And likewise, I'm going to give you 48 hours to do that, but that you don't take with Respondus, and it's not timed. And you can collaborate with anyone who's in the class. If you want, you can come to class period on that Thursday, and you guys can work together in class together. I'll be here answering questions, like clarification questions, things like that. But I won't give you any answers to that. But if you want to do that, to come here and say, there's a couple of us that want to work together at that time, then you can talk to each other. It'll be like a group assignment. But you don't have to. You can work on it at home. You can use Slack to collaborate. You can open up your own Discord, whatever you'd like. It's up to you, just so long as you're only collaborating with people enrolled in the class this semester. It's open book, open notes. Any resources that I provide on Canvas are legitimate, they're legal, including Canvas itself. But I don't want you going searching. So, Chegg and those sorts of things are not they're not official things that you can use for this stage 2. It is the exact same exam as stage 1. It will be 20% of your score. So your total midterm score, which I think is 20% of your total score for the class or something like that, that will be the combination of these 2. So it's kind of like you do 80% of that on your own. And then after seeing that, if there's some stuff that you weren't quite so clear about, you can work with your other people in the class to try to make everybody stronger at that. And that's what you do with stage 2. So that's the way that's lined up there. After stage 2's availability window disappears, which again, I think I gave 48 hours for both of these. So that'll be Friday night when this disappears. Then that weekend, which is the weekend going into fall break, then the solution set and scores will become available. So you won't know your scores or the solutions between these two. All right, so any questions? I'm gonna stare here. So I already see some questions. So somebody already asked, first question, will stage 1 be available the whole period? Yes, so stage 1 will be available from midnight, so like from the very earliest morning Tuesday, all the way through Tuesday and all the way through Wednesday. So from midnight Tuesday morning to 11:59 Wednesday night. That's stage 1. Stage 2, from midnight Thursday morning down to 11:59 Friday night. So a full 48 hours for stage 1, 48 hours for stage 2, but it's timed for stage 1, not for stage 2. Another question, will Zoom be open for stage 2? I'm happy to do that. It's going to be weird if you want to, like, I'll open the room for sure. It's going to be hard for me to facilitate collaboration with people in the class, but if you want to like collaborate with people on Zoom during the class period, I'm happy to do that. So I can sit here in the class period proctoring, open up Zoom like I normally do, and you can have sort of a cluster of people working together in the class, a cluster of people working here. Of course, for stage 2, you don't have to submit anything when you leave. So when you leave the class, you can keep working all you want. The other question is, will stage 1 provide scores after completion? Then no, you won't provide, you get no information about your scores, what you got wrong, what's right in between these. All of that comes after both stages. Questions from the class? Pretty clear. How many people here have ever taken a 2-stage exam? Okay, so it's a relatively new thing in pedagogy. I've been doing this for a couple of semesters in several different classes. And I find that I think I used to do retakes, where the retake was a totally different exam than this exam. And that would end up, I think, helping scores a little bit. But this I found I've gotten a greater increase in scores in the midterm by doing these stage 2. And I find that when I do assessments after the exams, I get a little bit better retention. And I think that it provides a little, it's not quite as much anxiety relief as a whole nother retake, but I think it does provide some. So I've been pretty happy with it. But I'd love to hear your feedback on it. So after you go through this, if you do have any like burning feedback, I really like this, I really hated this, please let me know. I'd love your candid feedback because these things are always a little bit in flux. Any other questions online about the format? Okay, good. So, all right. So resources on Canvas. So like I said, if you take that Respondus lockdown browser compliance test, you pretty much just open that up in Respondus browser, open the quiz up, and I think there's like one question that said like, answer yes to this question or something, and you answer yes, you hit submit, and you're done. You'll get your full credit on that. And then that will open up all the midterm resources, and that's where you can find sample midterms. There's like 6 or 7 sample midterms, including a practice Canvas midterm that you can take without Respondus. There's the solution sets for all of those past midterms as well. Of course, there's homework solution sets have been available. There's Canvas activities. So the ICAF, I actually meant to make ICAF due before this class. I don't know what happened when the dates got shifted from the last semester to this semester, but somehow it got due tonight. So you apparently have all day today to do it. So I didn't update the due dates. I intended for it to be due already. That's why the slides say practice Canvas activity. But once ICAF does go away, there will be a practice ICAF that doesn't score points, but is the exact same Canvas activity. So you can use that for practice as well. And then if you need extra help, if you don't like my notes and things like that, each one of the lectures has got a chapter associated with it. And so that tells you where to go in the lecture textbook to find more information about the topics in that particular lecture. So those are some resources. I think I've kind of already covered all of this, that we won't have any new lecture material Tuesday and Thursday of next week. I will be here Tuesday and Thursday during the lecture period, but there won't be any new material. So the next lecture we have will be after fall, will be the Thursday after fall break, lecture G1. And, so there's no new material until after the midterms are done. And I said formula sheets. All the statistical tables I will give you, so you don't have to copy down the chi-squared, thresholds, anything like that. That'll be in there, but you should know how to use them. And it's of course going to be Canvas style. So I take questions I would like to ask in sort of free form, and I figure out how to turn them into a numerical answer or a multiple choice answer. I do like these kind of select all questions, so select all of these answers. The nice thing about that on the old style Canvas quizzes I use is you do get partial credit for the multiple answers, at least until they force us to go to so-called new quizzes on Canvas. You still get partial credit for those, but every question, unless otherwise noted, was worth 1 point. So even like the questions take you a long amount of time or 1 point, the short amount of time or 1 point. So there's not as much of a question about like partial credit, and that's kind of what I'm saying here. And yeah, the whole exam together, both stages, is 20%. All right, question online: is the ICAF a good representation of how the exam questions will be formatted? A great representation of how the exam questions will look is the practice midterm. So I put on in unit F2, the practice midterm is the midterm from last semester. I stripped out a couple of admin questions at the top, but otherwise the length and content is going to be very similar to this midterm. It's not going to be a copy of it, but that is a great example of what the Canvas-based midterm for this semester might look like. ICAF is, I think, a lot of those questions, they're based more on the book. They're a little bit different flavor, but they cover the same content. But I would say that the style of question is going to be more like the practice midterm that I put on there in that unit F2. Any other questions about formatting and such? So this is just trying to answer that same question that was just asked. What sort of stuff would you expect? I mean, when I build the midterm, my mind is like, I'm going to open the midterm with multiple choice questions. I would like to then do several small numerical questions, and then some design problems like random variate generation. But then I have to take all these and compress them into kind of a Scantron Canvas-sized form. So I already mentioned, like, if I ask you to build a random variate generator, I might give you random numbers, like I'll just give you a string, 0.123, 0.765, whatever. And then I'd say, after you've done your random variate generator, run these random numbers through it and give me the random variates out. What random variates did you get out? And I could ask you that as a numerical question where you have to put in the numbers and I'll accept it to some significance, or a multiple choice question where I give you some options and then you choose among those options. And you can see examples of that in the sample midterm. Okay, so general questions before I think we get into any other, your technical questions. Pretty clear what's expected and the timing and everything. Okay. All right. So at this point, I don't have to cover any of this stuff. I have some general homework feedback on the 3 homeworks here. And then after all of that homework feedback, what I've done here in this ICAF is I've basically gone through and organized a review where I basically cut the material so far into discrete event system modeling, probability, and random variates. And on the slides here, I went through all of the lectures, like lecture A1, and I pulled out what I thought were the greatest hits from those lectures, the things that I think resonate most with me when I'm thinking about building a midterm. And so if we want, we can slide through these slides and to see if it generates any questions. But the main thing I want to do is, if you already have questions, I'm happy to answer them. I've got the tablet hooked up here. So if you want me to work some problems like a random variate generator or something like that, I can throw that up on the screen. So before I do anything that's pre-cooked here, does anybody have any questions or questions that they looked over in the review material that they didn't understand the answer for? Is there anything? Yeah. The Kolmogorov-Smirnov test. Sure. So the question was, can we do an example of a KS test? So maybe I'll flip And then there's a question online, which I'll get to right after this. So what I'm going to do is just stop this share and go ahead and all right. Oh, and then let me full screen this guy and move this text down here. All right, so so there's a question then about a KS test. So Kolmogorov-Smirnov test. So the KS test is, I would give you a string of random numbers. So I could say, you know, like 0.7, 0.2, 0.95, 0.1, 0.853. That's going to end up sucking. So 0.85. Okay, so I just give you a string of random numbers, and then I might ask you then use the KS test to assess whether these are likely to come from a uniformly distributed random number generator. So my null hypothesis here is that these numbers are drawn from a uniformly distributed random variable between 0 and 1. All right, so what's the first step in a KS test? Anybody? Yeah. Sort the numbers, right? So let's sort those. So if I look through here, then it looks like I've got I'm going to just give myself a little bit of space here. So I'm going to put this in 0.1, 0.2. The next one's 0.7, 0.85, 0.95. All right, and so at this point, I've got them sorted. And I know that if they were uniformly distributed, once I've sorted them, then roughly speaking, the first number, so roughly speaking, this number should basically fall in the first, it'll be sort of proportional to its ranking where it falls. And so since there's 5 numbers, this should be in the lowest 20%. This should be in the next 20%. This should be in the next 20%, next 20%, next 20%. So I'm expecting this number here, this first number, to be between 0 and 0.2, where this up here is going to be, this is 1 divided by n. And I guess I could call this I divided by n. And this is going to be I minus 1 divided by n. So n here is equal to 5. And we consider this column, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5. So if I were to write these things out, maybe I'll put this top row in a different color. This will be 0.4, 0.6, 0.8, 1.0. And down here, this bottom one will be just lagging behind that by 1 step. Okay. So, so I've just created these intervals here, and I am now need to evaluate how well these numbers, my random numbers here sorted, fit into each of these intervals. And so what I'm going to do is I'm just going to calculate the differences between these 2 numbers and between these 2 numbers. And so the difference between 0.2 and 0.1, well, those are 0.1 off. The difference between 0.1 and 0 is also 0.1 off. I can do that here. These ones are 0.2 off. This one is 0 off. Here, 0.6 minus 0.7, I could put negative 0.1 there, but it turns out the negatives won't end up coming into play because we picked the maximum. So I'm just going to put a dash there because it's negative. But then between 0.7 and 0.4, I'll put a 0.3. Between 0.8 and 0.5, that's another negative. Between 0.85 and 6, this is my fear of doing math in public, I think is 0.25. Between 1.0 and 0.95 is 0.05. And between 0.95 and 0.8 is 0.15. So now in black here, next to each one of these arrows, I have a list of differences that represent kind of how far away the numbers are from their kind of expected interval if these were uniformly distributed. So from that, I can look at the, I could calculate, well, what's the highest, it's traditional to calculate the maximum of the top row here. So the maximum of this thing. If I look through that, it looks like it's 0.2. And the maximum of the bottom, which is down here, looks like it's 0.3. And then my D for this KS is just the max of D plus and D minus, which is just going to be 0.3. All right, so now I've calculated my statistic for the KS test. It's just this D over here. And now I just need to know if I have an alpha of 0.05, then what is the critical value D alpha N, which in this case would be D 0.055 for this. And I don't have that table up in front of me, but I could look that up by these two here. And I think it's like 457.457. Again, I don't want to quote that for sure. So I would give you that table. And if I could look that up, then I could compare these two numbers here. And if the 0.3 was greater, so I'll say if greater, then, that's a greater than with an E, reject. And so remember, the null hypothesis is uniformity. Yes, so this D here is just the maximum over all of these differences. Does that make sense? So the questions about that, Kolmogorov Smirnov.
Greater than the max between the D plus and D minus. Less than the B failed.
Unless I misheard you, I think the reverse of that. So I'll write it right here. So if let's get a different color. Hold on one second. So if the statistic D is greater than the threshold that we look up, then reject. So D is like the distance to the null. So if the distance to the null is too big, reject. And then there's a question, should D, you said should D plus? D plus is just the first row. So when I do a KS test, I don't, just traditionally when books teach this stuff, like our book, they separate out the two rows and they say, what's the max of the first row? What's the max of the second row? I think it's an extra step that just confuses things, but it's in the book, so I put it in there, but it's just the max of all of these things. Other questions? Is that clear? Let me see online. Are there questions about that before I move on to the next question, which I see in the chat. Yeah.
On the example, do you have to go into detail explaining why we're rejecting saying or if we fail to reject sufficient evidence that would be
Well, because it's going to be sort of canvas based, I have a limit in how deep I can query things. But you could imagine me putting multiple choice questions where some of the questions would be conclusions that you could. So I could give you this string of numbers, and I could say, and then you could imagine a multiple choice where I might say, like, by the Kolmogorov-Smirnov test, we accept the hypothesis of uniformity because, or whatever, and then you would have to say, well, there's an aspect of that logic which is not right, so I'm not going to choose that one. Well, that's excellent question. We will get into that a little bit more in the midterm. The only thing you can say for certain is reject. So we can reject uniformity. But the KS test happens to be one of these so-called high power tests that it is very unlikely for it, if it doesn't reject, it is very unlikely that it did that inappropriately. So it has like a very low false negative rate. And so if it can't detect a difference from uniformity, we feel much safer about the KS test just saying, okay, it is uniform. So that is one of the cool things about the KS test. But in general, for now, let's just say that if you can't reject, then we want to use the phrase like fail to reject. So we can't actually draw a strong conclusion, but if you reject, you can draw a strong conclusion. So if this D becomes way too large, then in that case, then you can say that it's definitely not uniform. All right, any other questions about this KS test? So far, we're going to find out a way to, after the midterm, how to use it for any other distribution. But we're basically, all we're going to do is take the numbers from the other distribution, run them through their CDF, and that will turn them into like uniform numbers that we can then test.
Yes, what do you mean?
Somebody unmuted on online. I just wanted to see, is there a question or is that an accident?
That was an accident.
Right.
My apologies.
Okay, no problem. Any other questions about the KS test? The next question in the queue is, I have a question on how to solve a linear congruential method. So, if you want to give a more specific, or if you just want me to generate some random numbers using a linear congruential generator. It was between 0 and 1. So, but do you have as a review for the linear congruential generator, the LCG, that an LCG will always generate numbers between 0 and 1. And an LCG will always have the general form that we're going to have some multiplier, I'll call it A, times some seed or previous value, I'll call it X, times plus some increment, I'll call it C, and then that whole thing will be mod, the modulus, whatever that is, which I'll call it M, and then that number, so that's going to generate the next, so if this is X of K, that will generate X of K plus 1, so our R of K plus 1 will just be equal to X of K plus 1 divided by the modulus. And this number here will always be between 0 and 1, because when you take a modulus of something, it's always going to be less than the modulus. And that's why this number is always between 0 and 1. So with that there, is there a specific question you had about that? Or does anyone have a specific question about the LCG? Yeah. There's a multiplicative congruential generator, which basically just forces the C equal to 0. Yeah, and then there's I think that there's a special name we have for when C is specifically non-zero. I think it might be mixed or something like that. Yeah, but I'm just going to use LCG. I don't really care about the taxonomy underneath that. So just linear congruential generator is this general form where C could be 0 or non-zero.
Oh, okay. So
Right. Let me make sure. So online, were there? Okay, that works. All right, so that clarified things online. Any other questions about the linear congruential generator? Only other sort of, while it's up, thing that I'll mention is that the LCG is if parameters A, C, M set properly, then LCG is uniform and independent for any seed. But what's the general problem with an LCG? Anybody remember what the one kind of thing that we have to deal with, and so we use combined LCGs to deal with this? Yeah, it repeats quickly, so it's like a short period, short repetition period. And so the solution is the combined LCG, where you combine multiple LCGs with different periods together, and you can end up getting much, much longer periods. All right, any other questions about that? I'm not going to ask you about the middle square method. I generally want you to know, when it comes to random number generation, uniformity and independence, that those are the required features. There are a couple of desired features that they're fast and all those sorts of things, but the big thing is know your uniformity and your independence, and know that a combined LCG gives you a much longer period, because a long period is the other thing that's practically, like, it's practically required for any random number generator. All right, there was another question online. Can you review the chi-squared test for uniformity? Specifically, one of the questions from the midterm review based on example 7.7 on the book. And so I don't have the book on me. Is there a particular, you said from one of the questions from the midterm review, is there a particular question number you can give me so I can pull that up? And if not, I can just do a chi-squared. Question number 30, and you say from the midterm review, do you mean ICAF or do you mean a particular, like, previous midterm? Okay, it's going to be difficult for me to bring up ICAF. Is there any possible way that you could sort of ask, what specific aspect of that question was the issue, so I can kind of regenerate it? It's just difficult for me to bring up Canvas and ICAF and find question 30 live. I mean, in the meantime, I can just sort of, to see if it inspires any questions. I can, for the chi-squared test, if I gave you a bunch of numbers, I mean, there's a couple things here. Is I'm probably always going to give you many numbers, so many samples, because the number of expected, if there is a specific question that really we need the ICAF question 30 to answer, send me an email. That way, when I'm at my desk and I can log into Canvas a little more easily, I can pull that up. And or if you've got a screenshot that you can send me that I can take a look at really quick on my phone or something like that, then I would be happy to do it. So if you do find a screenshot of the issue you're having and you want to send it to me, put something in the chat, I'll take a look at my phone and pull that up. Otherwise, you can send me an email offline, and I'm happy to answer that question about ICAF. So for the chi-squared test, I mentioned that the expected number in any one of the bins has to be greater than or equal to 5. I might ask you about this, but generally, if I ask you to do a chi-squared, I'm not gonna put you after the midterm. I might put you in the position where you have to decide between the chi-squared and the Kolmogorov-Smirnov. But this time in the midterm, I will specifically tell you, you need to do a chi-squared here. And if I tell you to do a chi-squared, it will be the case that you'll be able to do it. So the expected number of that will fall in each bin will be at least 5. So you don't need to worry about that thing. Otherwise, the chi-squared test is very similar to how you might have done in, I guess, 380, or maybe some of the other classes you've taken. How many people are in 474 right now? All right, a lot of people, okay. All right, so I feel like in past years, the schedule was a little bit different, that a lot of people took 470 at this period. Now it looks like we're overlapping 474, which will be good after the midterm, actually. So are there any specific, does anybody have any issues with the chi-squared test since the chi-squared test came up? Are there specific questions, clarifications? It's hard for me to do an example without, I can bring up the example that I gave in class because that already has 30 numbers. Me to do an example up here, it just requires a lot of work for me to come up with, enough numbers and so on. But I mean, the basic idea is I would give you, somewhere around 25 to 30 numbers between 0 and 1. I would tell you to split things into probably 4 or 5 intervals. I would probably specify that. And the expected count per interval would then be the number of samples divided by the number of intervals. For example, it might be 25 divided by 4, as 1. So that right there, or maybe I'll just make it easier. I'll just do, let's say it was 30 divided by 5. And then that would give me 6, which satisfies everything that I would need there. And then at that point, then you just count how many numbers are in each bin. And those counts will go into the observed counts. We'll call them OK. And then from that point, you can calculate difference per bin. And you put it in this funny little statistic where you say, well, I'll take the observed count in bin 1 minus the expected count in bin 1, square it, divide it by the expected count. I do that all the way up through my top bin. So we'll say there are 5 bins in this example. So E5. And notice that when you do the chi-squared, you don't square the expected in the denominator. After the midterm, we'll explain why that's the case. It looks funny, like it looks like the units of the numerator don't match the units of the denominator. But after the midterm, we'll see that it's not an accident. And so that will end up giving us our chi-squared value, which we then will compare to the critical value. And that critical chi-squared value, the degrees of freedom will be the number of bins minus 1. So in this case, it's 4. And but the alpha is still going to be equal to 0.05. And so you look up for this 0.05 because it's a positive statistic. We don't have to worry about it being two-sided. So that's why it's 0.05 and not 0.05 divided by 2. But you do have to subtract 1 from the number of bins. So your degrees of freedom will be 1 less than the bins. And that's how you look up. So you look up 4 degrees of freedom with that alpha, that will give you the critical value here. And just like the KS test, if this thing is bigger than the critical value, you reject. Question? Don't have to worry about combining bins this side of the midterm. On the other side of the midterm, we'll combine bins. But but so foreshadowing that, or thinking about 380, if there was a bin where this wasn't the case, then in that case, you would combine with a bin adjacent to it, and you sort of optimize to maximize the number of bins such that all bins meet this requirement. So maximal degree of freedom meeting this requirement. And if that's not possible, you just choose a different test like the Kolmogorov-Smirnov test instead. But that's kind of post-midterm material. You won't have to combine bins on midterm. Okay. So I had another question come up in the chat. Are there other questions in the room? Okay. It sounds also like the chi-squared question in the chat might have gotten resolved. All right, so there was a question in the chat for things like number of emails received in an hour. What is the distribution? What's the right answer to that? Does anybody have a thought about, if I were to ask you, what is a good input model to choose when you're modeling the number of emails received in an hour, or the number of calls received in an hour, or something like that? What do you think would be a good distribution there? Why Poisson? I hear a couple of people say Poisson. Well, it's related to a rate. So the Poisson has a rate. Yeah, it's a count. So that's one of the things. So, so if I want to say number. Okay, so if I was modeling the number of calls in an hour, so what you should think there is, one, this is a count. And so I want a discrete random variable. A discrete random variable. So that's one thing. So that excludes all of our continuous random variables. It excludes the exponential, the Weibull, the Erlang K, all of that stuff. They go out the window. They don't work here. Now, I would probably say the number of calls in an hour, and I might say given, independent inter-arrival rates or inter-arrival times or something like that. Inter-arrival time. And so in that case, we would say, there are a bunch of different discrete distributions. What's a discrete distribution which represents kind of the number of arrivals when the time in between the arrivals is independent? And that independent inter-arrival tells me that if I don't know any other information, that Poisson is probably the discrete distribution that I want, because a Poisson represents the count of exponentially distributed inter-arrival times that arrive independently in any duration. So a Poisson has a parameter alpha, which we can view as lambda tau, where this you can think of as an exponential rate, and this you can think of as a duration. And so if I were to say people arrive at 5 students per hour, and I say, and the duration is 2 hours, then I would expect that in 2 hours, I would get an average of 10 students. And so this Poisson random variable, how many students do I see in 2 hours? The alpha here would be equal to 10 students. So that's how the two are related. Questions on that? So that's a good question, because those are types of questions you expect in the midterm too. I've given you kind of an outline of a few of the like really fundamental random distributions that we should have in our vocabulary. And so if I ask you for like, I want to model X, what's the best one out of these 6 distributions, then you should be able to pick that out. I typically will say, I want to model these 6 things, match that to these 6 distributions, only one will be used at a time. That's typically what I do. So sometimes that makes it easier. Yeah, there's a question in the back, I'm sorry. I'd say ICAF will help you brush up on the right material. If you really want to know like what the test is going to feel like, that practice midterm that was like a copy of the midterm from last year is a good one to do. Any other questions regarding this? Yeah.
So we were asked for the interarrival time between two calls.
Mhm. I would say that given no other information, if all we know is that that interrivals between calls are independent and we know their average or something like that, yeah, I'd say an exponential. Generally, waiting time between independent events is an exponential. Not always. I mean, like waiting time between failures could be Weibull or whatever, but like the default choice is kind of exponential, and then we can kind of, based on the situation, we can shape it in different ways. All right, let me see. There was another question in the queue here, I thought. Okay, no, it looks like I'm all set, all up to date in the chat. So any other questions here? Everybody feel pretty good about your inverse transforms and your random variate generation? Once upon a time, that's where I would get like the most questions. So maybe not anymore. Yeah. Sure. So example, random variate generation. You mean like starting from PDF and going all the way through? All right. Let me see. I'm gonna have to keep this relatively simple so that I can do this on the fly here. But like let's say I did a random, this is so probability density function, area under the curve has to sum to 1. So I will say it's, we'll say it is got a density of 1 from x is negative 0.5 to 0. And then it's got a density of x from x is 0 to, let's make sure I don't screw this up, I think 1, because it's triangle. Yeah, that should work. So so just this density function that I just kind of peeled out of the air. So if I were to plot that thing, it would be, this is x, this is little f of x. It would be a 1 from 0.5, negative 0.5 to 0. And then from this point, it would be a line that goes back up to 1 like that. So I've got, it's this solid piece here and this diagonal piece here. And if I think about it, this area underneath this rectangle here, that is 0.5. And if I did this right, again, terrified of doing math in public, but if I did this right, then the area underneath that triangle should also be 0.5 because it's got a base of 1, a height of 1, 1/2 base times height is 1/2. So I know that is a probability density function. So we're good. So now I need to calculate my CDF. So that is the integral from negative infinity to x of little f of x dx, which I need to break into 2 parts. This top part is going to be the integral from negative infinity to x of 1 dx for 0.5, negative 0.5 less than or equal to x, less than or equal to 0. So, so this thing here is the antiderivative of 1 is just going to be my dummy variable, which I could call x or tau or whatever, and then I have to evaluate the limits. And so I'll call this thing, I'll just create a dummy variable called delta, and that's evaluated from, oh, and I'm sorry, I didn't mean to do that negative infinity. That should be minus 0.5. Because it's 0, the integral up to minus 0.5 is 0, so I don't worry about that. So, so it's from negative 0.5 to x is this thing. My dummy variable I'm just going to call delta, and I'm going to evaluate that from minus 0.5 all the way up to x. And then that thing here is just going to turn into an x plus 0.5. And that's going to be the top of this CDF. And that I think should work because the CDF will then start at 0 at the far left-hand side, and it'll climb to 0.5 at the right-hand side. So that's the top row of the CDF. Everybody okay with that so far? Before I do the bottom row, things get really interesting. Online, any questions with that? Okay. All right, so I'll flip colors again here. And so in the bottom row here, I have to split this bottom row up into the contribution from the top row plus the new contribution, the marginal contribution from the bottom row. So the initial contribution from the top row is going to be from minus 0.5 to 0 of 1 dx, and then plus from 0 to x of x. So this is where this dummy variable. So I'm going to use delta. Maybe I'll use tau, d tau. So I just swapped in a dummy variable, so I didn't have to have x's in multiple places. And that's for x between 0 and 1. And so this little portion here, well, I've kind of already done that in the previous one. I just have to evaluate it on the right-hand side of it, and that should be just a 0.5. Yeah. Oh, yeah, I'm sorry. So the question is, I was sloppy on these guys here. And so on the midterm, I would make sure that I didn't have this ambiguity. So one of these would be less than, the other one would be less than or equal to. For a continuous random variable, it does not matter. As we get more advanced, there are random variables that mix discrete and continuous, and then it does matter. So if I were to plop in probability mass somewhere in here, then it would really matter where I was including that mass. But if it's pure density, that single point has no mass, so it doesn't matter. All right, so this part is 0.5 from above. Does everybody see where that comes from? I could just do this definite integral out, but it's the same thing I did here, just evaluated with x equal to 0. So that's just 0.5. So I plug in the 0 there, I got a 0.5 out of there. So then I got to do this part. And so I know the antiderivative of tau is just tau squared over 2. I'm going to evaluate that from tau is equal to 0 to tau is equal to x. And that thing here is just going to give me a 1/2 x squared minus 0. And so this bottom row here just becomes 1/2 x squared plus 0.5. And so now I've got both portions of my CDF. I'll highlight. This is the top row, this is the bottom row. Any questions on that? I'm getting from the PDF to the CDF. And if I wanted to plot that thing, then the CDF here would be this x plus 0.5 would end up being kind of climbing until it hit 0.5, and then this 1/2 x squared plus 0.5 would kind of curve up until it hit 1, and then it would flatten out. So this is what happens right here at 1. This happens at 0. This is at minus 0.5. So this is what big fx of x will look like. And all of these things that I'm writing down here, I will share after class on Canvas. All right, so any questions about that, the CDF? Then we have to invert the CDF, which we'll do. I'll switch to the next page and do. All right, so I'm just going to rewrite that CDF. If I remember correctly, it's x plus 0.5 for minus 0.5 to 0, and then it's, did I do that right? Yeah, and then 0.5 plus 1/2 x squared from 0 to 1. And so I need to invert this thing. Well, I know that this here is going to correspond to an R range from 0 to 0.5. So by plugging in this into here, I get 0. By plugging in this into here, I get 0.5. I also know that if I plug in those same bounds here, it'll go from 0.5 to 1. So if I plug in the 0 into here, I get 0.5. If I plug the 1 into here, I get 1. And so that's how I get those two intervals. So what I'm going to do is for those two intervals, I'm going to invert this piecewise. So I'm going to set, for the top one, I'll set R is equal to X plus 0.5. And that's going to give me that X is equal to R minus 0.5 when R is in the range of 0 to 0.5. And if I set R is equal to X, I'm sorry, R is equal to 0.5 plus 1/2 X squared, then I have to do a little bit more work here. So then I get 1/2 X squared is equal to R minus 0.5, which tells me that X squared is equal to 2R minus 1, which tells me that X is equal to plus or minus square root 2R minus 1. So then the question is, which one of these do I choose, the plus or the minus? Anybody have a guess there? Should I choose a plus or a minus? So remember that I'm plugging in R values from 0.5 to 1 into this, and I want X values from 0 to 1. Positive, that's right. So I'm going to choose the positive value because I want X, let's maybe circle this here, because X needs to be between 0 and 1. And so that's why I chose the positive. And so those are my two halves of my random variate generator, this one down here and this one down here for this range and for the R in 0.5 to 1 range. And so at this point on the midterm, I would probably give you some R values. Like I might say, well, let's just say that R is equal to 0.457. And then I would ask, what would X be? And you would look at that and I'd say, aha, R is equal to 0.457. That is in this range here, which means I plug it into here. So 0.457 minus 0.5 gives me, again, terrified of doing math in public, but negative 0.43 maybe. So that's a negative out there. Yeah.
So like this X value is supposed to be within the range of
Yes. The original support, yeah, this X value is supposed to generate over the whole support of the random variable that we were trying to generate.
how do you which X why do you pick that positive square root?
So I chose for this one down here, I was focusing on this R range, 0.5 to 1. And that was just from back here. I had two ranges. I had this half of it, which corresponded to this guy, which corresponded to this part of the CDF for this range. So for this range of the X values, the R values I get out, or the CDF values I get out, are going to be between 0 and 0.5. For this range of X values, when I plug that in to the CDF range I get out is this range down here. So you can view these as the CDF ranges. And you can view this as the X ranges. And so I'm just mapping from the CDF ranges, which will always be in the range of 0 to 1, to the corresponding X ranges. Does that answer both of those questions? I think they were related. The one mapping from these CDF ranges here to these X ranges here. So this range here corresponds to this X range, and this range here corresponds to this X range. And that's just because this X range corresponded to this CDF range, and this X range corresponded to this CDF range. They just have to match. Oh, right. So here, I'm going to plug in R values that are from 0.5 to 1, which is going to mean that the thing inside this square root is going to be between 0 and 2. Sorry, it's going to be between 1 and 2. So this part here, this 2R, that will be between 1 and 2. And that allows for the discriminant inside this thing, or the dividend will then be guaranteed to be positive. So the divisor here is guaranteed to be positive. So this part of the thing is positive. So in order for, since the square root is positive, it's not imaginary, in order for the X to be positive, I want to put a positive there. So that's the only thing. If I would have happened to have an X range that was negative, then I would have chosen the negative for that. But I chose the positive because I wanted, for this R range, I wanted this X range to be positive. And that's why I chose the positive. For this, well, so this R corresponds to this range, which corresponds to this X. And that's why I plug this one into that formula and get this output down here, which is negative. So I could have chosen an R that was 0.9. And if I would have said, if my R is 0.9, what would my X be? In that case, you would then plug it in to this expression down here. And you would, that's right. So on a midterm, I would say the random number generator in ARENA, in Excel, gives you this value, 0.457, or it gives you 0.982. What does your random variate generator give you? So you then plug that in, and that will be what you answer on the midterm. Questions online? Okay, I've got a question here. After you plug in the R value and get the X, do you then plug that X value in to get the F of X? You can plug the X value back into the F of X to check your work. Because if you've done everything correctly, then if I plug an R value, so if I have F inverse R, that's going to give me some X value. If I then take that X value and I plug that back into F of X, I should get the same R value out that I started with. So if you want to check your work, so this is to check work, then you can do this back and forth, where you take the R value that I give you, plug it into the generator, get an X value out, take the X value, plug it into the original CDF, get an R value out, and that R value should match the R value I gave you. If it didn't, then either your inverse or your CDF, you should revisit because there's a problem there. Does that answer the question online? Any other questions? Everybody remember the sort of modeling philosophy that, all models are wrong, but some are useful. A model is defined by what it is used for and not what it is made of. Models answer what if questions. Those are sort of other things. Anything else? Does anybody else want to see? Mm-hmm. How to interpret the muffins? Oh, so hand simulation. Yeah, you should know how to do hand simulation for sure. So if I were to, you could, I could give you a table that would be very similar to that, whatever that was, the first, I don't know if it was the first homework or the second homework. This is the first homework, the second problem of the first homework, but I could definitely give you a table that would be like the kind of cashier problem that was in that second problem of the first homework. And where I would give you, you know, so you'd imagine a clock, you might have a number in the queue, a number in the server, you might have a checkout line, a future event list, and then maybe some cumulative statistics like the number departed. And what I might do is I might populate part of this, but I might leave something out. Or I populate, you know, most of the first row, but then I ask you questions about the second row. So you should know how to get within a row, you know, fill in any missing gaps, assuming I give you enough information, or given, definitely given one whole row, how do you populate the next row? And this will be for simple single server or single channel queues. And so you've got, it'll be just for the case where you've got arrivals coming in to a queue and some server node. And so you've got, so you'll just have some arrivals. You know, imagine a single arrival rate and a single service rate. So arrivals coming in, service coming out with usually one server. So just like we did on the homework, just to make sure that everybody is comfortable with the kind of event scheduling worldview, that you can schedule events and read these future event lists. Are there any questions about the future event lists, event calendars, event scheduling, events, activities, delays, all of that? Okay, any questions online that might have kicked up? On the ICAF, it had questions looking in the book at a certain section. No, I won't ask you anything that refers to a particular section of the book. Stage one and stage two is a copy of stage one is, you know, it's meant to be, you know, self-contained in the particular. So I'll give you any tables. So I won't ask you to look at any statistical tables. Those will be given to you. The only things you might want to copy down is like for the runs tests. For the runs above and below, it's probably a good idea to copy down that expression for mu and sigma squared from the mean and variance, given the number above and the number below. Yeah, the number above and the number below. So that's a good one to copy down to have that, because I won't give you that formula. Yeah.
So in ICA, there's a question about the so it had a set of numbers. So I'm assuming the runs, we're setting this as 0.5, which is just to see the runs is about
well, the traditional thing we do with the runs test is to use the threshold we use as the average, so the mean, so not 0.5. So if I gave you a bunch of numbers, like, you know, between 0 and 1, so 0.1, 0.9, whatever, I will also, so that you don't have to worry about calculating yourself, give you the mean of those numbers. So the mean might be, you know, 0.65. And then you would say, is this number above the mean? It isn't, so it gets a 0. Is this number above the mean? It isn't, so, or it is, it gets a 1. So this number would get mapped to a 0. This number would get mapped to a 1. So the threshold here is the mean of the numbers. Any other burning questions? Again, I'm happy to flip back to the slides and just kind of blaze through them. And if you see something that looks scary, you can stop me. Or if you've got specific other things, we can handle that too. Questions online? Looks like there's nothing new there. All right, well, since we've got, looks like it's 11:41, so there's only a couple of minutes left. So I'm not gonna bother with the slides. So if there's nothing else you've got for me, then that's all I've got for you, but I'm happy to, I will stay here, right here until 11:45. If you have any other questions, feel free to come up. And likewise, I'll leave the online up as well. Oh, I also meant to mention, I sent out an announcement. I've been doing office hours this semester by appointment, and that's been working okay, I think. But for today and tomorrow, I also will just have an open office hour at 4 p.m. both today and tomorrow. You can feel free to come. I'm just gonna, when people get to the waiting room, I'm just gonna bring them directly in case other people have other questions. But if you just want to talk to me privately about something, you don't want to share your question with somebody else, send me a note. And then if I see you in the waiting room, I'll put everybody else back in the waiting room and I'll bring you in. So, and that's all I've got for you. So I'll hang around here if you have anything else. Anybody online have anything else? Otherwise, I will leave this channel open until 11:45, so for a couple minutes.
I actually think this might be the chi-squared question that they had.
Okay.
So I was gonna bring it up, but then I wasn't sure if I knew what they were talking about.
Okay.
So it's question 30, but they actually asked it two different ways. So they're saying that if you change the intervals of equal lengths, so if you reduced it from 10 intervals to 5, how many outcomes will be observed? So the key part to this question is observed. So that we're looking at the, and this is a table. So that we're looking at the observed.
Right.
Right. So the second question they had was the expected. What would be the outcomes expected in the first interval? So then that would be our E.
That's right.
So when they reduce the number of intervals, we just combined like kind of uniformly. So we would just combine the first two and then the second, or the first interval 1 and 2, and then 3 and 4, 5 and 6.
You've got it.
So if it was 20 intervals and then they reduced it to 10, we would do the same thing, like one interval and the second interval get combined together.
Right.
It would always follow that same.
Yeah, if there's that nice thing where it goes 10 to 20, if it went from like 10 to 15 or
Like
something
odd
like that,
number,
or
right?
then you have to rethink it and say, well, okay, so what I need to do is I need to take the 0 to 1 interval, instead of dividing it by 10, which 0.1, 0.2, whatever is my thresholds, now I have to divide it by 15 or divide it by 3 or whatever.
Right.
So you might have to change the thresholds and then recount. But in this particular one, yeah, went from 10 to 20 or 20 to 10, it's, yeah, you can just look at the table and combine things.
And then on the quiz last question, would we be given these table column, like the identity for the column, or do we have to memorize that? Or we take the difference from our observed to the expected and square it? Like, will we have to memorize this for that specific column?
No, well, I wouldn't give you a column. All I would do is give you numbers and calculate the chi-squared.
Okay.
So you just have to remember the chi-squared formula.
Okay. Thank you.
Hi.
Quick question.
Yep.
I'm just a little bit confused on how we go about choosing these bounds.
Okay.
CDF.
Well, so
I
that,
don't know if there's something to
well, I mean, it just comes out of the density. So
Yeah.
this density function is, I didn't write it, but it's 0 all the way up to negative 0.5, and it's 0 after 1.
Yeah.
So, so technically I could have created another row where I integrated up to negative 0.5 from negative infinity, but it would have
Okay.
just been 0.
Gotcha.
So that's
So you
the
just kind of skipped a step.
exactly. Yeah. Sorry about that.
So I remember that I travel and stuff. I come back, but I get here at 10 p.m. So I don't know if I can take it on Wednesday.
Yeah.
My
The
question-
availability is all day Wednesday.
Yeah, but like I come back on. So my question was like, if I could take it like on the class before or after the second part in person. Like I don't feel like I don't take it in person.
Before or after the second part? So your flight gets back 10 p.m. Wednesday?
Yes.
So you only have 10 p.m. to midnight.
Exactly.
you would-
Before I come back, I think bring everything. I have to take it.
Well, I mean, originally when I adjusted it, you just told me Wednesday. That's the reason why I gave.
Yeah, but like they changed the itinerary because or I mean I can try to take it.
I mean, I guess, yeah, I mean, I tried to be as flexible as I could, but at this point, well, that's, I mean, I mean, at this, I think the only thing I can do is, I don't think it's on lockdown. So I would say that if you can possibly take it while you're away, that's going to be the best option. Because I mean, because technically the stage 2 opens up, and everybody's free to talk to people or whatever. And so I really need all the stage 1s to be done by Wednesday at 11:59.
Then jigsaw puzzles, whatever I can again.
Mhm.